So the cloud continues. We're mid-afternoon. Our next speaker from Terremark is going to talk about evaluating enterprise clouds. Let's give it up here at Cloud Expo in New York to Chris, it is getting late. Chris Drumgoole, take it away, sir.
Hello, everyone. How is everyone doing today? So I'm lucky enough to have the opportunity to speak in front of you today a little bit. We've been given the opportunity to talk to you a little bit about what you should look for in an enterprise cloud as you're deploying it. There's obviously probably the fifth person up here to say it today, a lot of noise, a lot of hype around cloud. God knows how many Google results there are around cloud. So we're going to talk to you a little bit about what you should be looking for when you go out and purchase cloud computing services. So now that kind of begs the question of, who's this guy to tell me about it? So a little bit about credentials. We're in New York. You got to kind of prove why you're here. So Terremark, for those of you who don't know, we run, going on 2 years now, one of the largest public clouds out there. If you have participated in a soft drink promotion from a major hamburger chain, if you went to USA.gov, if you bought a car and got a rebate last year, you've used our cloud. And in the context of selling and working with those people, we've learned a little bit about what people look for when they buy clouds and what they should look for and what their providers should give them. So that's what I'm going to talk about. It's a little high-level tutorial of what you should look for. Hopefully just piques your interest in terms of what you should ask providers and pitchmen who are trying to sell you cloud when you actually go out to buy one. So if you go around, most people will tell you that it's cloud. You shouldn't care who you're buying it from. Pay no attention to the man behind the curtain because it's a cloud, and we'll do everything. You don't worry about anything. Well, I'll tell you that if you Google cloud outage, you'll see exactly why you should care who's behind the curtain. You will get numerous outages from numerous providers, and the overwhelming majority you'll see, and this is going to be a theme today, is that very few of them have anything to do with anything that is cloud. They are very traditional, old-school IT challenges that anyone in this room who's in IT has solved already once in the past. But because the providers got convinced that they didn't have to care about it anymore, it became an issue for them. So you absolutely have to care, and you have to worry about behind it. And now, more importantly, we are, again, in New York. We're not in the Valley. If you're actually already making money, not hoping about making money tomorrow on it, you have to care extra special more. You have to really worry about your cloud because things depend on it. So let's talk about why you need to care if you're in cloud. First of all, does anyone in this room think that the regulatory environment we all live in is going to get any easier over the next 4 years? We are only living in a world where Sarbox, HIPAA, PCI, and these types of folks, and ones that haven't even been named yet, but I assure you that we'll be talking about at the next conference next year, are going to be in your business, and they're going to want to know where your data is and how you're moving it around and all that type of stuff. Now, when regulators come around, they inevitably bring security guys behind them because they take care of everybody about the regulators. So now you're going to have more security policies that you need to worry about. And then we have what we call the CEO mailbox problem, a.k.a. the you're fired if it goes down problem. So we need to make sure that the business is responsive and understands what you're getting and that you're up and running. Now, again, you're running a business, so you don't have the luxury, well, some people do, but we don't have the luxury of being a startup where you don't have to worry about anything you've ever built before. Most of us have millions, if not billions of dollars in IT infrastructure that they've already paid for, and that you simply can't walk into your CFO's office and say, hey, we're going to the cloud, throw it away, don't worry about it, it's all good, you're just going to get a monthly bill. That just simply doesn't work. Also, most of us don't live in we live in an internet-centric, but not an internet-exclusive world. You have, if you're in a retail business, you have thousands of locations, you have manufacturing plants, you're scattered around the world. Simply being able to put something on the internet in a cloud environment is not enough. You need to be able to make sure that whatever you're going to use that cloud for works for your enterprise and works for your 7,500, or 75,000 sites that are around the world. And then finally, at the end of the day, the reason everybody's here and the reason everyone can pay to join is that your business gets revenue from your sites. So making a decision about where to go to cloud shouldn't be based on who's willing to give you a free credit in their bookstore, who has the nicest website when you swipe your credit card and run on the cloud. You need to look at it as an IT decision like you would anything else. You wouldn't buy your SAP or your next CRM or your Salesforce automation system just because they have a funky website and because it's really trendy. You shouldn't buy cloud the same way. So that being said, let's talk a little bit about why this is important. Because as you'll see today, everybody and their grandmother's in the cloud business. There is, if you name it, from people who sell books to people like us to people who run data centers, everybody's in the cloud business, and everyone has some sort of flavor of cloud, and if they don't, they've rebranded something they do cloud. So whatever they did before, they've rebranded it as cloud. So you really have to take the time to be able to cut through the noise and cut through the confusion in the marketplace and the pitches, and figure out what is actually behind the meat and the potatoes behind the offering. So, first of all, let's talk about the neighborhood. So we call this the representative of the noisy neighborhood problem. When you move into a cloud, you're moving into a neighborhood. You're going in with other people. Clouds are multi-tenant by very definition. Now, the two types of multi-tenant cloud that exist out there today are traditionally referred to as the commodity public cloud and virtual private clouds. And they each serve independent purposes. Neither of them is better than the other. But it's a neighborhood. Just like when you are looking for a place to live, when you're looking for your home, your needs are very different when you're a 20-year-old right out of school and you're alone and you're just trying to figure out where you want to go, versus when you're a middle-aged guy with your 3 kids and you're trying to figure out where you want to go. Your requirements and what's important to you are different for both of those two types of situations and scenarios in your place in life. And they're no different than your applications. So you need to look at each application and decide which neighborhood it belongs in and where it is. For your development application that doesn't have a requirement, the fact that you're with a whole bunch of other developers, or in this analogy, the guy playing his guitar at 3 o'clock in the morning, might actually be inspiring. Maybe you like the fact that he plays music at 3 o'clock in the morning. You like that you're around other developers who are hacking things up and breaking them all day long. And you get better ideas from that. And that's a perfect place to put your commodity public cloud. On the other hand, you may have a revenue-producing system, or if many of our customers are in the government space, a system that lives depend on. You don't necessarily want to be using those same shared elevators, hallways, and windows and stuff that everybody else is doing when you have no control over who everybody else is. So you have to look at your applications independently and decide which ones go where. So, kind of concretely, some of the things that actually differentiate these two types of clouds, and they're called out there, so I won't give them to you by name, but the important ones we really think are a few. And the first is that the networks are different. When you are in a commodity public cloud, your security tends to be what's good for the one is good for the many. So it's good enough for the cloud provider, it's good enough for you. You don't really have a lot of say, and you don't get to separate it out. In a virtual private cloud, it's much more like a gated community. You can separate your own applications, you can separate application A from application B, and you can live into your security requirements around VLAN segmentation, firewall segmentation, things like that are typically important in that type of environment. Another thing that we think is important, an important differentiator, and there are many, many more than are on this slide, is the availability of the compute pool. So is this compute pool something that's private, dedicated, and has guarantee availability to you? Or is it something where you're actually competing with your neighbor for resources and just trusting in your cloud vendor that it'll be available when you need it? These are important questions to ask. And if you should not move into a cloud unless you know the answer of which one you're moving into. So now that you know who your neighbors are, you have to talk about actually what they've built. Now, there are two dramatic types of cloud. There are two really different fundamental architectures in clouds today. There are clustered architectures and non-clustered architectures. If you think about it, all clouds are piles of processor and piles of memory with hypervisors running on top of them. At the end of the day, that's what an infrastructure cloud is, right? Certainly IaaS, which is what we're talking about here. Those things can fall into one of two areas. They're either clustered or non-clustered. Let's talk about non-clustered first. In a non-clustered world, you just literally have a pile of servers or a pile of processors, each one running a hypervisor, and there's your app all happy sitting there and doing its thing. Now, as we all know, and as much as hardware vendors don't like it to happen, things happen. Data centers go down, chips melt, power supplies fry, and boxes die. So now what happens if you're in a non-clustered architecture when your box dies? Well, it's a lot better than it ever was, don't get me wrong, but now what happens is you have to take your app, go to some object data store, some cloud-based storage, or some archive disk, or whatever it is, and you have to go get your app, and then you have to upload it into the cloud or clone it over. You have to either provision new resources or, actually more appropriately, go to your cloud provider and ask them to provision you more resources, which is typically a click of a mouse, but it's a step nonetheless. And then, assuming those resources are available, they'll get your app up and running, and then you're back in business, which I don't want to over-exaggerate. This could be anything from a couple seconds, but it can also be a couple minutes or even a couple hours, depending on the state of the world that exists at any given time. So let's compare that architecture to a cluster architecture. Same pile of servers, same pile of processors, but this time what the provider has done is put in a matrix environment, a clustering environment at the hypervisor level. So hypervisor A is talking to hypervisor B and C and D at infinitum. You have your same app running on a server, and the same chip melts. Listen, boxes don't not die because they're in clustered environments. The same box dies. Now what happens is the underlying cloud infrastructure, the provider or the hypervisor level, simply moves that app over. you probably still have a reboot involved. Maybe you got lucky and you didn't if there was some proactive monitoring and notifications, which is something you should ask about. But now instead of a massive upload, a manual process, or even a scripted process, it happens automatically. So you've taken a lot of steps and a lot of risk out of the equation. You get some other values too, though. If you have other apps of yours or your customers that are running on there, and things happen naturally, your provider can move those apps around without you knowing about it and without you caring about it, more importantly. So when a server needs to be taken down for maintenance or a server needs to die, you can move things around and you can go on forward. So you actually, and finally what that brings is the provider can then bring in intelligent load balancing, intelligent resource management, and things like that to manage your pools. Again, I'm not trying to tell you that one of these is better or worse than the other, but again, it comes down to knowing what your application is, what your tolerances for downtime are, and why you should be on there. So now we've talked a little bit about kind of architecture and neighborhood. Let's get down into the next step of detail, which is actually what's the thing made out of. And it's the balance between reliability and redundancy. Now, there is a school of thought out there that is very prevalent and getting a lot of press that says you don't have to care about how reliable it is because it's cheap, plentiful, and you can get as much of it as you need. So who cares if the server dies because you can just buy 50 of them. Well, I assure you that if the pilot gave you that article, that story when you were getting on a plane, don't worry if one of those vintage 1967 engines die. We have 4 of them. We're good. You wouldn't take it. No sooner would you want to get on a plane that has one big engine that's really, really well maintained and probably not going to fail. So you need to take the same approach to your cloud environment. It's a balance of reliability and redundancy. What are the trade-offs? How important are the underlying things? Now, Terremark, we've kind of taken a school of thought that says these things break down into 4 categories that you should look at. And the first is the data center. And it's actually the most prevalent. It's the easiest to see, especially if you go back to my comment earlier about Googling cloud outages. A lot of them have been data center related. Data centers break, right? They're probably the weakest chain in the link. Power supply. Power equipment requires maintenance. Power grids, especially in some of the developing parts of the world, but even in the United States here, are not as reliable as they once were and can't be counted on. Natural disasters happen. Things fall into the ocean. So you need to go and take a look at your data center. You need to make sure that that it is a data center, right? That it's a tier 3 or 4 data center, and it's not a couple guys who had a startup and turned the office space next door into a data center by throwing some APC UPSs in there. So you want to actually go and walk through it, right? You shouldn't buy it. You wouldn't put your servers in a co-location environment into a data center site unseed. You should do the same with your cloud. So any cloud provider that tells you, whether this is commodity public or virtual private, that don't worry about where it is because you don't need to care about the data center, you should certainly care and your sensors should be going off. It's not something you should be just taking for granted that they know how to run a building. There's an art and there's a science to it, as facility guys will tell you, and you should pay attention to it. The next kind of pole in that tent is network infrastructure and connectivity. And this really comes down to 2 things. It's the actual kit that your equipment is running on, and it goes back to my do things break. Switches, routers, firewalls are computers at the end of the day. They have processors, and they have memory, and they have chips, and they have silicon, and they have power supplies, and those things break. And how well they're manufactured makes a difference. And again, I don't care that you have 2 switches. No one wants one of them to die. No one wants to live in that world. We all know when things die is when things happen. So you want to pay attention to the equipment that the gear is running out of. And then you want to look at the connectivity, because in the relentless pressure to drive cloud computing costs down, a lot of people are choosing substandard bandwidth. And you want to take a look at what's going on and where is your bandwidth going out. And is it great that your price went down 20%, but your average page load time went up 60%? Or your sales guy out in the field office can't do a demo anymore or take an order because he can't get to the application? But hey, you saved $10. So you have to be paying attention to that type of stuff. The next is servers, the actual kit that the thing is running on. As my wife constantly reminds me, I am a geek, and I have manufactured servers in my living room. I have made them in my past, I am not proud to say. I'm telling you, you don't want any one of those servers running air traffic control. And the same thing approaches when you look at the servers that your cloud provider is running. Everyone in this room has read the stories about the guys who create servers using Velcro, and the guys who have open air rack servers, and the guys who have all this and that and the other thing. And that's great if you're a massive provider running a single homogeneous environment where you really don't care if a server goes down. However, if you are a cloud and you have to provide service to multiple different types of business units, where maybe your Oracle database doesn't like the fact that it had to reboot, you have to be paying attention to the underlying infrastructure. Mean time to repair on underlying equipment actually makes a difference between being down for a minute every couple of years and being down for a couple minutes every couple months. And those 2 things make dramatic differences to your business. And then finally, the storage platform. One would think this goes without saying, but it doesn't. When you buy a laptop, odds are you look at how much storage you get, how it's accessed, And even this is actually changing for just the iPad and things like that. But you want to know how fast that drive is spinning, how big it is, and how it's connected. You want to know the same thing about your cloud. A lot of applications, we will live in a world someday where apps don't care about storage and they won't. We're not there yet. And applications care about I/O, and they care about access to disk, and they care about how they see it and what's presented. So you want to ask the tough questions about the storage infrastructure. How is this thing connected? How redundant it is? How well does it perform? The next step is security, right? I don't know how many security people are in this room, so I don't know how many people I'll offend with this. But you can't have a cloud conversation without security people hijacking it. It is what it is. It's the world we live in. We joke at Terremark that we don't have cloud conversations. We have security conversations that have a cloud subset that we talk about cloud with them. So you need to put it on the table and you need to talk about it. So we view cloud security as really a three-prong approach. And the first is the actual architecture of the system. And when I say architecture, I don't just mean the architecture in terms of how is the application structured and how is the hypervisor level structured. It's everything from that, so how is the network configured, how the hypervisors talk to each other, how do the admins who are managing this stuff access the hypervisor, who has that access, when does it happen, how does customer A not talk to customer B, what are those processes and performance, how is that architected, how is that physically designed not to happen, how are those walls manufactured, how are those switches put in place. It's physical security. All that stuff is great, but if you go back to my data center analogy, if it's sitting in a room where your average hacker can sneak in and plug into the wall and be at layer 1 on your switch, well, then the fact that the thing was architected really well really doesn't make that much of a difference. And then how do you actually get your users to get into it? How do you make sure that you know that so-and-so who just got released from the company 2 days ago doesn't have access to the cloud anymore? Is it integrated into your single sign-on? Is it integrated to your other systems? Is it integrated to all that type of stuff? And do individual users have individual user rights? These are things you want to ask. The next leg of that kind of security stool is the model around it and the security services around it. Because you could build the best prison in the world, and if you don't have any guards, someone will eventually get out. So what you need to do is actually look at your provider's security model. And don't just say, well, we got firewalls in place, so we're good. How are those firewalls monitored? How are they managed? How are they upkept? What are the certifications of security people on that staff? What happens? How do you respond when someone attacks them? Just to give an analogy, there are a few sites in the world that attempt to be hacked more often than the United States government. And I can assure you that you could have the best security services in the world running on USA.gov, the latest and greatest firewalls, the latest and greatest encryption devices. You give that thing a couple days, maybe even hours without someone looking at it, and it's going to go down. There's just no way around it. It's an arms race, and you need to have people on your side of the fence manufacturing those arms with you. And then finally, it goes back to the point I made earlier. It's compliance and audit. Again, anyone in this room who deals with credit cards, thinks about credit cards, processes credit cards, has a credit card in their wallet and happens to work in IT, probably has to talk about PCI compliance these days. It's really everywhere we go. So you have to worry about things like that. Now, for those of you who are familiar with the PCI, HIPAA, FISMA, FDIC, these types of standards, you know that no cloud provider can come in and say, well, don't worry, we're HIPAA compliant or we're PCI compliant. If they do, you should run for the hills. But what they can do is tell you how they can help you become compliant, because the compliance is actually, the end game of the compliance is on you as the end user. Now, what you should be looking for in your cloud provider is someone who says, Mr. Customer, Mr. IT person, there are these 800 or 400, I don't even know how many there are, things that you need to do in order to be PCI compliant. Let me show you how I help you on these 300, 200, whatever it is. Let me show you some other people who have actually managed to fix these other 50, and let me point you in the direction of some folks who can help you with the last 20 if you don't have the resources yourself. And how can we make that process easier for you and happier for you? Because again, don't be fooled just because there's HIPAA compliant or PCI compliant applications on a cloud. That doesn't mean that you will also be compliant by moving on to that cloud. Let's talk a little bit about I alluded earlier to legacy devices and legacy systems. Now, again, very few people have the luxury or the ability to work in the exciting times of a startup where you actually get to build everything from scratch. So we have a lot of stuff. There's a lot of vendors here. I mean, there's some big red Oracle cars in front of this building. I assure you they did not get paid for because no one bought Oracle over the years at a lot of money. So people have a lot of stuff, and you need to make sure it's going to continue to work in the cloud. And that goes everything from your applications and your networks, which we've already spoken about, all the way up to your infrastructure and your investment levels. You have actually got to look at the systems that you've put in place. So you have massive investments in security models. You have massive investments in IT management tools, people like Tivoli and HP and these types of folks out there. What you don't want to do is save 20% on cloud or 70% on cloud, but increase your management costs by 50% because you didn't think properly about how that thing was going to interoperate with your existing systems. Now, another thing, and this is a controversial one in the cloud world, is standards. How do you actually make sure that you avoid cloud lock-in and you avoid getting stuck with one vendor? We think this is an important part, and it's certainly the most controversial in the cloud world because there really is no standard. So at Terremark, we've decided to actually standardize on VMware. That's the decision we've made. As the gentleman up here before me talked about how he's going with KVM, and there are people out there who are based on Citrix, there is Zen, there's open source, and there's probably, if there's a hypervisor, there's probably a cloud based on it today. And I'm not here to tell you one is right or wrong, but what I am here to tell you is make sure you know which one you're getting into once again. And make sure you know that when that relationship between you and your cloud vendor sours, or you decide for whatever other reasons that you decide you want to move off, that you haven't just built in a giant roadblock to getting yourself off of that cloud. Or even, let's look at it positive, that when you need to expand onto that cloud, that application that's running on a cloud, and you need to move into Asia-Pac or the Middle East or someplace where maybe that particular cloud vendor doesn't have a presence and you need to go with an alternative vendor, that you're now not in this thing where you're managing two systems at the same time. And then finally, we think API is important. It's really a matter of being able to integrate your cloud with your scripting, your ability to automatically do things. GUIs are great. I'm going to talk about them in a minute. But at the end of the day, when you start talking massive scale IT, you want to be able to make sure that you have an API underneath things that lets you automate tasks, lets you script things, and move along like that. So next thing in our kind of stack, and I should have had a whiteboard where I could have written these as we went through them, but I think you can get copies of the presentation, is usability. How do you actually use this thing? So sticking with my plane analogy from before, if you look at that cockpit, I assure you, I don't know what it's from, my marketing guy could tell you, but I assure you that it runs something highly complex and powerful. I also assure you don't want me anywhere near it without years of training. Now, what you don't want is your cloud to run the same way. So you can have the most powerful cloud in the world and has all the functions and all the features, but if you need people who have gone through 6 months of training with the vendor and no one really knows how to use it and you got to tweak this wizard or change that setting in order to get performance out of it, then really what have you done besides transfer some CapEx from your side to your cloud vendor side? You haven't done much. You've still kind of kept that complexity. So you want to look at your user interface. You want to make sure that your GUI gives you the power to do what you need to do, but at the same time makes it so you don't need a degree in high-end engineering with your master's in something else. And by the way, I've been to a 7-month training class to try to figure out how to use it. You want to make sure that you can get reports out of it. You want to make sure that you can get the stuff that you're used to getting out of it. Importantly, and this is surprisingly overlooked by cloud vendors, you want to make sure that you can have user A be able to do things differently than user B, be able to do things differently than user C, and you ought to be able to make sure that you can audit and keep track of them. So user A needs to be a full admin, user B needs to be a read-only, user C needs to be billing only, or any such permutation of the above. That's an important thing, and it's not something that's present in a lot of clouds, so you want to take a look at that. We talked about the API a little bit. And now this is simple, and it's kind of the antithesis of the VARs in the room and around. But it needs to be easy to buy. I mean, part of this whole story is I can spin things up and down very quickly. But as anyone who's tried to place a last-minute order for a bunch of server gear that they needed because something went wrong, we all know that's not always the easiest process. And you need your cloud purchasing process to be simple. So as much as I make fun of the website and I make it that you don't want to make your decision on that, when you do make a buying decision to either upgrade, downgrade, or purchase, you want that process to be easy, seamless, and painless. So you should actually ask your cloud provider who you're speaking to, how does this actually work when I say yes? How do I buy from you? Which kind of leads me down towards our natural conclusion. And at the end of the day, clouds are piles of servers, as we discussed, and they need to be easy to run, and you need to be in good data centers. And all of that stuff that I've talked about is run by people. It's designed by people, and it's run by people. And that's how it works, and that's how it will continue to work for the certainly foreseeable future. So you need to talk to and meet those people. You need to know who's selling you your cloud. You need to know who's running your cloud. You need to know who they are, and have they done it before, and do they know what they're doing, or they just have a really good pitch and a really good story and a really good grasp of current industry buzzwords. You want to make sure that they're qualified to run your operation. An important one, and this is overly looked, is you want to know about how you communicate with them. And this is probably the biggest one that, quite selfishly, this is one of the biggest one that has probably driven business to providers like Terremark, is when something goes wrong, and it invariably will. We all know this. This is IT. Things go wrong. Whose fault they are doesn't matter. What happens? How do you get in touch with the people who are running your cloud? Is it a fill out a form, click submit, and pray? Is it a fill out a form, click submit, get a bill for $500, and then they'll talk to you? Or any one of the above? Or is it, sometimes there's phone support. Is your phone support, you're calling Mike, who you've met 10 times before, who knows your business, knows your application, and knows everything? Or are you calling Chip in an offshore call center who actually just knows the answer to your cloud and he's reading you a script? These are the things you need to pay attention to, and these are the things that are probably the most critical when you're making your cloud decision. And then finally, and this is kind of a nice thing, is we all like the single-stop shop. There's a reason Walmart exists. There's a reason Target exists. And it's because we like to get things in one place. And there's a certain benefit and efficiency to getting your things in one place. So what you do want to pay some attention to is, can your cloud provider provide anything other than just pure cloud? And can they help you with it? It's a factor. It's not the only one, but it's something you should pay attention to. To kind of wrap up, everything I've discussed so far today ends in SLA. And I kind of love and hate this slide, and I hate to talk about it, because when you put SLA up there, you infer that it's purely a numerical thing and it's purely about the number of nines after a decimal point, and it's not. I assure you, I can give you as many nines after a decimal point as you give me pages to write small print. There is absolutely nothing to do. The number is not a number. The number should be reflective of everything I've just discussed, and it should reflect the overall spirit of the relationship between you and the cloud provider. Now, it should absolutely have teeth. You should have an SLA that says when I go down, I get money, I get to leave, I get whatever. Your SLA should not be, I get a really sincerely worded, pitch from your CEO saying, hey, sorry about that. You should make sure the SLA has the appropriate teeth in it and has the appropriate items in it to make sure you're comfortable. But at the end of the day, you need to look past the lawyers. You need to look past the number. And you need to actually look at that first draft of an SLA you get from your cloud provider and say, okay, I've been through this process. I know my vendor now. I think I know what they've sold me. I think I know what I'm talking about. Is this document, their out-of-the-box document, reflective of what they've told me and what they've pitched to me? And right there, that's the ultimate sniff test. So the SLA is extremely important, and it's something you should all look at. So that about sums it up on my what to look for in the cloud, and what I will give you is my last minute. I have a sales guy in the room, so I'm obliged to do it. I'll give you my last minute pitch about Terremark. If you want to learn a little bit about how we've done this and stuff, I ask you to come by, visit booth 110, where we are handing out shiny cloud cards, which you can take home and punch in the code on the back and go home and try $25 worth of brand new, never been used before, free Terremark cloud. And if this whole conversation stresses you out too much, we have stress balls, so you can pick one of those up too. But so that's about it. I thank you all for your time, and I appreciate you having us.
Thank you so much, Chris Drumgoole. We are doing another quick flip. Google is up next. Thanks again. So I'm going to have those stress balls, please. Well done.